start recording? Yeah, so the first thing I had for the background improvements demo today wasn't exactly related, but it was something I was working on and that took a while, so I thought I'd share it. I'm just gonna share a screen and hopefully I'll get this right. So should be able to see my browser now. So we had an issue where the ASAP queues were just not processing any jobs, but they weren't failing on anything. They were just completely saturated. And we sort of had a look, and it's quite hard to debug this after the fact. Like if we would have been able to catch it during the incident, maybe it would have been easier using perf or something to catch this. But you can see here that we're sort of guessing about the rate that we're adding to the queue, but we can see that basically the processing rate went down instead. So we don't think that we're pushing a bunch of jobs. We just think that some jobs are being slow and that those jobs are, consuming all the worker capacity, and we're stuck. We've got some InfluxDB dashboards still hanging around, which are actually really useful for this. So that's because they instrument certain Ruby methods. That instrumentation may also actually slow down GitLab to a certain extent, but we'll cross that bridge when we come to turning that off. So what we can see here is big spikes in some of these methods here, in wall time and in CPU time, which is important because while Scikit's multi-threaded, Ruby does have a global interpreter lock. So, most of the time that's not a huge issue because although Ruby's slow, you're doing slower stuff like by going to the database or by going to Gitly or by doing something like that. But if you're actually being slow in Ruby, you're blocking any other threads from processing as well. I don't really know how to correlate these ones, to be honest. They're just weird. I think it might be that something was happening inside a transaction for the SQL timings. I've got no idea about the cache timings. Since this, we've added database timings to the Scikit logs, which actually probably would have been a better demo subject, but never mind. So what's happening here is that we're pushing to a branch, and this is probably going to be easiest actually if I show the code. If I show the code, so sorry, I am. Oh dear, I don't normally use my editor from a terminal, but it's easier to share the screen from the terminal, so I'm doing it this way. So services, and then it's branch push service. So when we push to a branch, we do sorry, I've got a different key binding when I'm in my editor normally. So we update some MRs, we do some general stuff. The interesting part is executing related hooks, which is about webhooks essentially, but also I think there are a couple of other types of hooks, but basically we're talking about like pushing a change out to somewhere based on the change that's just been pushed to the repository. For that, there was some correlation up here in branch create hooks here. We also had a second incident a little while later where you can see again the latency spikes because there's no workers available to pick new jobs.
Can I interrupt you just really quickly?
Yeah.
That graph, is it total time or self time on those method timings? So is it the time that it's spending in itself, or the time it's spending in itself and all of it's like downstream?
I haven't actually looked at that, but these methods do. So obviously the wall time is the method and all downstream.
It's total. Yeah, it's total. Yeah.
CPU time, I'm not 100% sure if it's self or total, but I think based on later the problem is something related to that. So it's either in that method or like that method doesn't have a huge stack below it, basically.
Yeah. Okay.
So yeah, we've got here that Stan shared the CPU time, and the Gitly duration, which are both high. So those are correlated to each other, and we can see an influx again. We've got this time in tag push service and also in commits between, which is weird. And one of these projects is a mirror. So I've got a production console open with the mirror, but I'm not going to share any confidential information because this is a mirror of the GitLab website. So it's actually quite convenient for our purposes here that this is going to work. So, you know, here's an example of what the, post-receive projects are. I just realized I also need to look up what the GitLab websites project ideas. So let's call that upstream. So right, we've got two projects in our console. We've got the mirror and we've got the upstream. Now they've pushed this commit and we're trying to figure out how many commits are between the default branch and this commit. So when you push a new branch, we say like, how much does this diverge from the default branch by? So here I'm going to use the commit char rather than the branch name because the branch has actually been deleted from www.gitlab.com, and you can see that return pretty quickly, and that's there's nothing because this is actually quite an old branch. But if we look at where master was, so this is a mirror. It's pushing to a bunch of branches at once. I'm not quite sure why. Maybe they restarted mirroring or something. Maybe, I don't even remember if it's actually a GitLab mirror or some kind of manual mirror. So master at the point we were testing this was at this commit. Master at the point this push actually happened was at this commit. So if we do this, and I'll just get the timing for that, and also output the counts. I mean, this kind of speaks for itself. Like, it's taking a lot longer. So what's happening is we've essentially got a very diverged branch. So that took 10 seconds to get 54,000 commits. We've got a very diverged branch. In this case, it's because the mirror has mirrored other branches before the default branch. So like ideally when you're mirroring, you would mirror the default branch first if the logic's like this, because if you're checking from how much things are diverging from the default branch, you want the default branch to be as up to date as possible. But even if we did that, we would still have this issue if you just push two branches that diverge significantly, right? Like, you know, there's nothing in Git that says you can't have two branches that diverge by 54,000 commits from each other. So yeah, and on the mirror, it's basically the same. It's 54,424 commits, obviously, because we're comparing commit chars, and it still takes 10 seconds. The other thing is, which I've actually done here because I did the wrong thing, is that you can see if you do benchmark measure instead of real time, that's a significant amount of that is actually in Ruby. Like, you know, we're not just waiting for Gitly, we wait some time there. And I think I've demonstrated this in the issue. That part of that is
why it's got such a high CPU component, I guess, Sean.
Yeah, so part of that is due to, I didn't fully look into it. I think part of that is actually due to deserializing the gRPC response, because I think it's a streaming response in that case. But part of it is because we do this decorate thing, which I think is, yeah, in repository. So let me see if I can actually use my editor now. Yeah, so we do, basically we call repository commits between, which this is the raw Gitly call, essentially. And then this commit.decorate just wraps them in a Ruby wrapper class that has some extra handy methods for the application to use. And this itself is quite slow CPU wise when you have this many commits. So I think in this issue here, it's like a second on a console box, which, you know, isn't actually going to cause this incident, but like the console box has basically no load. And, you know, when you have multiple Sidekick jobs doing this, it gets trickier. So the actual really frustrating, or not frustrating thing about this, but I guess the good part is that we don't actually need all these commits. So if we go to the branch hook service. Sorry, base hook service. There's quite a bit of inheritance here. No, maybe branch hook service. Yeah, okay, here we go. So if we're creating the default branch, we get the commits, but we limit it to this process commit limit from Gitterly. Otherwise, if we're creating a branch, we get all the commits. But in the base service, we then have this limited commits method that takes that array of 54,000 commits and gives us the last 100. So we're asking Gitterly for 54,000 commits and then throwing away all but the last 100. But when we push the default branch, we just ask Gitterly for the last 100 commits. Now, at this point, I was like, yeah, great, okay, that's the issue. There is actually one other nuance here, which Drew Blessing, support engineer extraordinaire, discovered, which is that you can actually get a deadline exceeded error anyway when pushing the default branch, even though it's limited. And the reason for that is when you push the default branch, we request 100 commits from Gitterly, which is great. But that means we have this override here because we also need to know the count of commits. And we don't want to just return 100 all the time because 100 is quite a low limit. So it would be not ideal. So we have this. Yeah, so we call this special RPC to count the commits in that ref, and we get all of them. And that can actually also exceed its deadline. So we still need to limit that one. We probably need to limit that to a higher limit than just 100. But in this case, they were pushing, this was on a self-managed instance, so it's not directly affecting scalability in the sense that it's not on gitlab.com. But when pushing, like, you know, a branch to an repository that's the Linux kernel, that that can easily be like over 100,000 commits away from another branch. And obviously, if you push the Linux kernel for the first time, you're still going to count all those commits initially. And I haven't actually checked how many commits there are.
What consumes that, Sean? Just to, like, if we just cropped it at a certain number, like what would that count commits in branch?
Yeah, so this is the frustrating part. So this is just for the webhooks, as far as I remember. So right. Where am I here? So yeah, we do limited commits is used for processing the commit messages. So where we might reference an issue or something in a commit, that's going to happen there. But we only do that for the last 100, like I said. What is it called? Commits count. One second. Just gonna use that in a environment where I can actually use my keyboard.
Also, while you're doing that, a question to Andrew, like, is there a reason why we can batch those things? Like, even if we need to do more than 100 commits return, like, do we need to do it in one go?
I mean, certainly from the point of view of Gitterly, because it's like Sean mentioned, it's a streaming RPC. So Gitterly and the Gitterly client are kind of batching in a way because, well, at least the Gitterly server is sending batches back. But then generally on our side, it's much easier just to then take that and stick it into an array rather than pass the batches on beyond the Gitterly client, because that's like, you're obviously pushing that complexity down into the application. But like, I have thought often, I mean, I don't know if there's a general sort of consensus around this, but like if you returned it like an iterator rather than an array from things like that, you know, then you could push 100 through, and the next thing down could consume those 100, and, you know, obviously better than, but it's...
Yeah, and Git's fairly amenable to that because you can sort of, you know, you can easily pass off where you got to, right? But it is quite a lot of extra work for, maybe we should just say, like, you know.
Yeah.
And actually, that's another thing here. I don't know where 9999 comes from, but the projects in the first instance where there was so this is a fairly large project, but not necessarily the biggest project that showed up in the CPU usage list, had a commit count of 99999. which is a little bit suspicious. So maybe that's some limit that we hit somewhere elsewhere that I don't know about. The other place this is used is for creating events on your like user feed, but I think again, you could reasonably say like if someone pushes 100,000 commits, we don't care whether it was 100,000 or 10,000. Like
Yeah.
Fundamentally, like that's not super important to everybody. So yeah, that's that one.
So this actually kind of ties into something I said at the the isolation working group. Like one of the things that would be amazing is if in our integration tests for these kind of events, we added something that pushed like 50,000 commits in a single go, and actually had that as an integration test to kind of prove that this will never break again.
Yeah, and in this case, it's really like it's kind of a balance, right? Because there's always going to be a case where you can push the limit. So like one person pushing 100,000 commits is actually fine because that will block one Sidekick node, but not all Sidekick nodes. The problem is when you have a few pushes like this at the same time, like we did in the mirroring case, that blocks all of them. And then we could add more nodes, but we would still have the same problem. So we need to make sure that our sort of maximum time is low enough that we can still get things through the queue, or that we've got another way of routing those so that they don't block everything.
Thanks, Sean. That was super interesting.
Yeah, sorry, there was no actual finale to that. I'm done.
It's to be continued type of story. I thought it was great as well. Yeah, thanks. Andrew, you were up next.
Mine is like really not that important. It was like a little hobby side project. So we've got like 10 minutes left, I think. Have we got, how long have we got?
Yeah, no, for 45 minutes.
For 45 minutes. Okay, I'll go quickly. Okay, cool. Share my screen. Actually, I'm just going to bring my proper mouse back because it was flat. I've got one of those stupid mice you have to run upside down. Back. Nope, I'm going to go back to the old mouse, so I might also not be very good. Okay, so a little while ago, this was quite a long time ago now, actually. I built this little thing where we can build a system diagram and have it in Grafana. And the really nice thing about it is that the color coding on the system diagram is based on like the error rate or the aptX or whatever. So you can get like different colors to kind of signify like what part of your system has the most errors. And then theoretically, you could look at a triage dashboard and you could see that like the most errors are in Petroni, and that would help you kind of go down to that kind of thing. And it was kind of just a little thing I was messing around with Mermaid and Grafana, because I'd seen a bunch of people at Prometheus conference who were using it to good effect, and it inspired me. And then Marin said like, but can we auto-generate this? And I was like, no, we're going to maintain this manually. And obviously that's rubbish because it'll never stay up to date. So I started thinking about like what the next thing we could do with it is. And then I thought, well, it's actually quite easy for us to auto-generate this. And so we've got this thing that I've been kind of working on the side called the metrics catalog, which is a way of describing like all the metrics in the system in a simple way, and then generating all of the key metrics recording rules from the simple instructions into like the more complex ones, so that we don't have to maintain those complex recording rules ourselves anymore. And so we've got this metrics catalog, and I'm kind of slowly going through all the services, and I'm adding all the services in here. So instead of having like recording rules across 4 or 5 different files, we've just got one thing. We say, you know, for CI runners, we've got 2 components. One's called the polling components. And for that, we look at the GitLab workforce builds register handler requests method. And we have a second component called shared runner queues. And this is how we basically monitor that. And this is actually the one that we're doing. So Eric said all CI queues have to run within 95% of CI runner queues have to run within 1 minute. And this is where we actually have recorded all of that and we're doing all of that. So what we kind of figured is that, or what I figured is that you can take that and you can add to that like the dependencies, and you can say this service, the CI runner service, has a dependency on the API, and the web service has got a dependency on Giddily, Redis Sidekick, Redis Cache, Redis, and PG Bouncer. And so this is this new stanza that I've added to the description of each service, which is basically saying the downstream services are these things. And actually, I was thinking it might actually make more sense to put this into the service catalog rather than here. But this is the first iteration of it, so we can have it here. And then what you can do with that is it's very easy to go from that to generating a Mermaid diagram. So if I go and I say test dashboard, let me make this a bit bigger. Maybe people can see it then. And then I say, sorry, I'll get there eventually. What you can generate from that is this. And so instead of maintaining a Mermaid diagram, you're just maintaining the downstream dependencies of each service, right? So I've just added it as a new row at the bottom here, and then hopefully this now will come up with the system diagram. And as my wife pointed out, it's really not pretty, but it could be super useful. The other thing is that at the moment, this has only got the things that are in the metrics catalog. So as more things come into the metrics catalog, we get more things here. The other thing that you can do with it is in, say, the Giddily page, we can just have one that's Giddily and its downstream dependencies, right? And etc. The other thing that you can do in future is we could say, we could kind of count the layers, right? And so if you start getting a bunch of alerts from, say, the API and Redis cache, it's pretty easy to say, well, the API is dependent on the Redis cache. So like, let's prioritize the Redis cache as being further back, and we'll kind of escalate the priority of those alerts that are coming through. Because, you know, the API, if the Redis cache is performing badly, there's no way that the API can perform well. So like, let's focus on the downstream issues first. And it's not about hiding the upstream ones, it's just about prioritizing them by the depth. If you get what I mean. And so that's pretty easy to do. But yeah, it was just a little demo of generating that stuff automatically, the Mermaid diagrams automatically from this. And the other thing that I did was I took the tiers and I put the services inside the tiers. So that also all comes from the service catalog. I don't know why these are not inside a DB tier, but there's probably a good reason. Anyway, very short demo. That is it.
It's pretty awesome, Andrew. Like the fact that we don't have to depend on manual stuff is what makes me think that this could be actually actionable. So when we get that SRE in the team, we'll probably have them play with this a bit more and like structure it a bit.
Yeah,
because it can be very, very useful during debugging. Like right now, the only thing I keep thinking of is like, what is happening with the runners right now? Like, how can I like focus on that and figure out what's happening, right? Like, it's just, I'm a more visual person. So when you see something like this, it just kind of draws you to move.
And monitoring service at 91% error rate. Need to work
Which is
on
not
that.
Great. Yeah.
The rules are not set up properly. But you know, if Giddily had a very high rate, And, you know, then it would kind of be pretty obvious if you were getting lots of alerts in the system, and this was like the reddest thing, the most read, not reddest thing, then you know, it might be really obvious. So it's kind of an interesting thing to consider.
This is probably not possible because it's a mermaid diagram, but I'm going to mention it anyway, just in case. It would be really nice if when you clicked on Gitterly there, you could go to the specific Gitterly dashboard to say like, oh, hey, I see this is orange. Like, how do I drill down?
I'm looking into it. There are other tools that, like Mermaid doesn't seem to have linking like that, but there certainly are other tools, you know, maybe dots or something like that. The other thing I was thinking is like this could be incorporated pretty easily into that GitLab Com engineering blog. So you just generate like a bunch of diagrams for there automatically. But yeah, the linking would be super useful. And I agree, it would be great, but I haven't focused on it very much yet. But I just have a quick demo of that, and we can move on, I guess.
Cool. Osvaldo, I moved you to the next because Bob didn't show up. So.
Yeah. Yeah, mine is not really a demo, just an update for now because it's not in production. But it's great that we are going to start to record the enqueued rate for Psychic. So that would, for example, help for the first issue that Sean mentioned, the incident that we wanted to know, the enqueue rate, for instance. That would be valuable there. So yeah, next week we can go through the demo for this one. But for now, that's just an update. So maybe Sean's next with Sidekick YAML files.
Yeah, thanks Osvaldo. I'm just gonna try and demo this. Hopefully, hopefully okay.
Just another FYI, folks. Demo is whatever we make it to be. So no apologies needed that something is not snazzy and great looking. The point is discussions. Like we want to expose things and like get ideas flowing. So great or not great, I'm already like finding this all useful. Sorry, Jean, I needed to interrupt you there.
It's all right. I was figuring out what exactly I'm going to demo here. Actually, let me just share my editor this time because when I use it through a terminal, I don't have one crucial key binding, which makes it impossible for me to do certain things with muscle memory. One thing we want to do is at the moment we schedule Sidekick jobs by saying that, you know, these queues are ASAP, and these queues are real time, and these queues are, I can't remember the names, but like, you know, we have a bunch of names for like priorities, and it's kind of hard to like, you know, map them and like realize in your head like what the different priorities are. So Andrew's added all these resource boundaries. So like, you know, you can say a worker is CPU bound or it's memory bound. A worker has external dependencies. So like, you know, it needs to talk to external services to do stuff, which is great. So like we have all this and we have specs that validate that all workers set these if they need to. Well, not set these if they need to, sorry. That they are set if there are required attributes. So things like feature category are required. So we know that like, you know, if this belongs to issues, then we can eventually map that to a particular stage group because feature categories are more stable than stage groups. So this is all repeating what Andrew said before. So the idea here is to get that information into our Sidekick YAML files. So we have this allqueues.yaml file, which has a list of all the queues we have. So anything before a colon is a namespace. So if we say that we want to process cron jobs, we'll get all the cron jobs. We don't need to list them out individually, but if we want to pull some of them out separately, we can. So at the moment, this is just a flat list of names. So what we do is when we start up and, you know, say we had a cron job node, we would just say, run the cron job queues on this node. But maybe we want to actually say like run CPU bound workers on this node because this node has more CPU or stuff like that. So I haven't actually done that part yet. What I've done instead is made it so that this file is automatically generated. Sorry, let me just check the. Oh, okay, fine. So yeah, this file is automatically generated. So if I just stash that and then switch back to master, we'll see that right now it's manual. We do actually have a spec that ensures that every queue is in this file, but we don't automatically generate it, which is fine when it's just names. But what I want to do and what I'm doing next is going to change this from a, so this at the moment is an array of strings. That's what this is saying in YAML. What I'm going to change it to is an array of hashes. So we'll have not only the queue name and namespace, but also the other attributes that we've added. So we could say like, run all workers that relate to the feature category merge requests on a particular node. We probably wouldn't do that, but we could. So
why wouldn't we do that?
Because they don't necessarily have anything in common other than they're related. Well, maybe merge request is a bad example, but like just because things belong to a feature category doesn't necessarily mean they have like characteristics in common about what they need. Like some merge request jobs might need to talk a lot to external services, some might not. Some might only contact the database, some might do a lot of Git.ly work, some might do a lot in CPU, some might not. So
as a bit of an aside, at the moment the pipelines priority is pretty much that. The only thing that kind of gathers everything that's in the Sidekick pipelines queue is the fact that they're in the feature category of verify or whatever. I forgot what it is,
right,
but,
okay.
which is pretty weird. And it's exactly as you say, it's like a very strange way of defining a grouping.
Yeah, I mean, it's not, I don't think it's wrong. I just think there's better ways you can group them. Like,
I agree.
And one nice thing about grouping them that way would be that it would be super easy to like attribute things to a particular group, but it wouldn't necessarily be the most efficient way to distribute them that way.
Sure, sorry, I did miss a bit, so apologies if you've gone through this, but are you generating all the files now or just the one?
Yeah, so well, this was something I was going to explain. So yeah, at the moment we have, can't type when people are watching. So we have this all queues YAML. We have an EE version with EE specific queues. And we also have this Sidekick queues YAML. So the issue here is that the one on the left is all queues YAML and is used by Sidekick cluster, which is what we use, which is currently in starter and above, but I think we're moving it to core soon. And that's where you can start multiple Sidekick processes easily, each processing a set of queues. And then the one on the right is used if you just invoke Sidekick and pass it this config file. So actually something I meant to double check, because I think I checked this before, but I didn't trust myself, was when we actually invoke Sidekick in Sidekick cluster, I don't think we tell it to use this config file. So this is kind of,
I think, do we not still get the priorities from that file, Sean?
Well, we might do. I need to
the
double
weird
check this.
Sidekick priority, yeah.
Yeah, so this has the whole Sidekick priority thing where there's a chance of popping something off the queue that's higher if it has a higher weight. So what I'm doing in this change, actually not this change, because I just switched branches, let me just switch back, is adding weight as an attribute to a worker. So
I was going to say, are you going to have it as a number or as a, okay.
Yeah, so at the moment
I think we should have an enum, like low, medium, high.
Yeah, well, like this.
Yeah, and then, yeah, exactly. But I mean, I think if I remember, there's some in there that I just tried to, like someone's just gone and gone, oh, we need to make this priority higher, and they've just made it like even higher than that.
I think they're all 1, 2, 3, or 5 at the moment. But
oh yeah, that was it. It was the fact that it wasn't 4; it was 5. It was like, let's just choose a number and.
Yeah. I think Yorick did some work when he first put those together to figure out like what made sense, but I haven't worked through that myself.
I don't actually think that they make. Yeah. Anyway,
Anyway, so yeah, all I'm doing now is auto-generating this file as well. Once those are both auto-generated, then I can actually change the format of them more confidently. Like, I don't want to change the format before I'm auto-generating them, because obviously then, like, that's kind of painful. And before I change the format, I also need to change Sidekick cluster to handle both config file formats. So it's sort of a multi-step MR process that Oswaldo's got the first one of now. Hopefully the second one's done soon, and then we're good. So yeah, basically the idea is that once we've generated all these, Andrew's got a separate issue for being able to select using Sidekick cluster based on like a little query language. I guess you can just talk about that quickly, Andrew. We don't need to demo it right now, I guess.
Yeah, it's just a way of saying on the left-hand side, you can see the feature category latency sensitivity. It's basically saying, give me workers that have these attributes, and then it will run those together. So the idea is that you want to put all latency sensitive CPU bound ones together, but then also you might want to say, like say we find that there's a queue that's going a little bit out of control. We could say, do all of these except for this queue. And the language is very simple, because it's not like, it's just parsed by, it's like a super straightforward parser, but it's got enough expressivity that you can do pretty much everything we've got at the moment and a little bit more. Like we can say, exclude this queue, or include this queue, and things like that, which are kind of help with emergency situations. Yeah.
Which language would we use to query that?
It's not really a language. It's just like an expression. It's like feature category in X, Y, Z, and feature category in and latency sensitivity in CPU, memory. So it's more like it's something you can kind of parse with like split. Because you just basically split up the string, and then it's not even like a parser. It's just a really basic language. We could choose to make it
doesn't have precedence, basically.
Yeah, it doesn't have basically it's ands and ors, and then ins, ands and ors. But if we wanted to make it more expressive, we could do that, but obviously the cost is that it's more complex as well. So we've just got to, this is a very easy thing to parse and to understand. I ran it by, because obviously the kind of people that we want to run this are the SRE teams. I ran it by Craig Niskell, and he said, yeah, it's a bit of a weird language, which it is, but he understood it, and like he'd be very happy to use it. So people like Craig are the people that we want to run it by and see if they accept it as a reasonable language.
Or Java or Scarbeck, given that they actually have to port this into Kubernetes as well at some point and make it work there. So I kind of want to make sure that the work we are doing now with pushing the project export queue into Kubernetes is very much aware of.
Maren, your microphone is doing a bit of a number.
Nothing better than wires.
All right, this should be better. I was saying that this is why we should be all aware of the changes between one and other side, because right now the focus for delivery is one queue and making that function within the queuing system we have right now, the Sidekick cluster queuing system that we have now. And we might want to consider how, like, whether we can group things in another way as well, in an additional way that will aid the transition to Kubernetes. So right now, for example, project export is chosen for a couple of reasons, but one of them being like it's kind of easy to isolate stuff. So we might want to be able to include like more queues like that and have them automatically ported to
Yeah.
Kubernetes by this work already in the application.
Like what I would say is, if we chose non-latency sensitive IO bound jobs, like those are probably like effectively what's running on best effort at the moment. Those would maybe be like a good, and maybe we actually even choose a feature category, kind of, as opposed to what I was saying earlier about it's a silly thing to select on, but if we choose like low priority feature categories and kind of just bring them on as they arrive.
Yeah, I mean, I said maybe earlier I went a bit too strong, because there are actually some feature categories that have barely any background workers, or like we know that they're all fairly low priority, like epics perhaps. So, you know,
yeah,
maybe that wouldn't be a terrible
and just
idea.
as a way of kind of selecting so we can ramp it up over time. But yeah.
Are these categories already set in stone?
No, they what we did was we did like a whole bunch of horse trading, and we went through all of the jobs. And then about a week ago, actually the last time I was in this demo, which was last Tuesday, we discovered that there'd been a whole bunch of changes in the 3 months since we'd set up the original lot. And I just went and changed them. Like, I think, like portfolio management got renamed to epics or something. And so we changed them, and it has to match up with what's in the stages YAML file in the handbook. So, you know, John, do you know the thing that generates the categories page in the handbook? There's this massive page called categories, and it's like all the DRIs. Yeah, there we go. Sean pasted it in. The file that generates that is the file that we use to list the feature categories. So they're not arbitrary. They come from that same list.
And also because
they're very arbitrary, but in the scope of GitLab.
They go ahead, Sean.
Yeah, I think arbitrary or non-arbitrary is kind of a side point. The point is that these are how the feature categories then bubble up to stage groups, which is like what bubbles up to teams. So like this is how people are organized within the company, which is the thing we want to also be able to do, is like attribute things to a particular group. And there are some, like Mailers just uses like one queue for everything. And technically like one group owns notifications in general, but they don't actually own like every single email, like, you know, that we send. So that's kind of a harder one, but for most things it works pretty well.
So like the idea is, Skarbek, is that like something's going, a queue that we've never heard of, like the widgets processor queue is going, you know, using all the CPU and all the memory, and like we're all like, wow, the widget processor, and nobody knows what to do with it. You go and you look on there, you map that to the team. Widget processor is the widgets team. We can go into their Slack channel. We can say, guys and girls, we have a problem with the widget processor. Like, please, can you jump on the incident call now? And there's none of that sort of like, who's in charge of this? Who owns it? And then even if they say, we don't know anything about it, it's like, well, then you are in charge of it for now. And as a, you know, afterwards, you can send a merge request with the appropriate owner. But as it stands at the moment, you are the owner because it's literally in the code. Cool.
I guess another quick question I've got is
Yeah.
when we get around to categorizing the sidekick queues into their boundaries, like they're CPU bound or memory bound or whatever, do we have any category that represents ones that may have shared state, such as the pages queues, where they need to have an NFS mount in order to operate properly?
No, that's a really good.
We should absolutely do that.
Yeah, that's a good idea. That's a really good idea.
And I think we might also need a disk space one if we're coming up on project exports next. But yeah.
Is there
Maybe
an
we
issue
should
I
have
can comment on that?
tags. No, I think that's a new thing. The epics there, I would definitely add it to the.
So hopefully the work we're doing here makes it easier to add these attributes as well in future. It's the good news from that, but I think it's definitely an attribute we should add.
Yeah, both of those things. The one thing I'm wondering is,
who's creating that issue? Just to be clear here.
Skarbek, do you want to create it, or would you rather one of us create
I could create it. Where should I create it?
In scalability, and add it
Scalability.
to Epic at the top of the document. Thanks.
Because yeah, then we can exclude all the NFS from the Kubernetes. That'd be great. Cool. Shall I move on?
Yeah, I just gonna move my item around because I accomplished what I wanted. Andrew, go for it.
Okay. I just wanted to point out, yesterday I added something to the handbook, and it's like a horribly painful process, and it takes a long time, and like it's very difficult to figure out where to put things in the handbook because it's so big, and this information is very important to us, but probably not that important to lots of people in the rest of the company. So one of the things Maren suggested, well, it's not really ideal to put it in the handbook, and we discussed creating like a little GitLab com engineering site. And so I looked around. The first thing go-to that I went to was Hugo, because it's Go and it's a static site generator, and I looked at it, and there was like going to be a ton of work to get it to make a documentation site, and so I wasn't really happy with that. And I looked at a few other static site generators, and then I looked at VuePress, which is obviously based on Vue.js, which is what all of our front-end teams use. And I discovered that it's got a beautiful developer experience, as long as you don't mind using Node.js. And you kind of, it's like npm install or yarn install, like 3 lines, and it just works. And what you get out of the box has got like table of contents. It's got the thing along the top, so I included a link to the Pages site. And so the table of contents kind of matches the directory structure, which makes it really easy to kind of structure things. We don't need to like cross-link ourselves or anything like that. Got a bit of an ugly URL at the moment, but like if we get some good content in there, we could potentially have like, I don't know, GitLab com engineering or something, .gitlab.com.net, whatever. And at the moment, it's just got some silly videos and stuff, and that was just me testing if we could include like YouTube videos and other content in there. But obviously, it's not going to have surfing videos when it's finished. But take a look, you'll see it's the most simplest site. It's basically markdown files in a directory structure, and then everything else gets generated. So it's very easy to maintain, I suspect. And that's me.
What's the issue with the handbook, Andrew?
Maren, do you want to
Sure.
lead that?
Sure. The issue with the handbook is too much information. It is extremely difficult to find things these days. So what you should, like in my opinion, what we should at least do is have the handbook as the source of truth. Where do you find that information? So you go there and you type Prometheus taxonomy, right? And then that gives you the link, and where you have like these big pages where you can actually easily navigate, consume that information, and so on. Same thing for GitLab.com settings, for example, application defaults plus settings that we set. It would be great if we can have that in a place where we can actually show that in one go, automatically generated. Handbook is GitLab, the company place of information, and you should go there and type in GitLab.com defaults, and then that should give you only the link to where those details are, instead of you going and I don't know, grabbing or Googling for this application setting that was set to 3, for example, on GitLab.com. It's going to be impossible to find. So you still have handbook as a single source of truth, but the expanded information is in the documentation where it's more easily consumable.
Okay.
We'll see whether it's going to take off, whether it's going to be interesting to do. Yeah.
I think there was an announcement that we're going to split the handbook into multiple sub-projects, so maybe that would help. Although it's not really an information architecture change, it's more of a
But since this is just change. Markdown files, we could migrate to whatever they come up with.
Exactly.
That suits us. So
exactly. So that doesn't exclude us from that information. I didn't know that. Thanks for sharing, Sean. Didn't know that was that new? When was that announced?
yesterday. I'll put. Oh, it's not. Maybe
Ah.
it's not even approved yet, but I'll put a link in the doc.
Okay, okay, I didn't
It's
know that.
also in the CEO channel. There was a mention of it.
No, fortunately, don't have the time to read every Slack channel.
Yeah, we haven't actually done it yet. We're just thinking about doing it. Or gonna do
Okay,
it.
so while folks are thinking about doing that, we're gonna do it, and then we're gonna port things over to the new concept once they have it.
Yeah. So, you know, someone said the other day, it was such a pleasure developing on LabKit because you can kind of compile and get your test results. That was Bob. When you use something like this, you get the same feedback loop. Like it's like literally you change the page and it's there, and it's such a beautiful experience. And like, I don't mean to take that away from the handbook, but it is like, it's a real pleasure working on it because it's so small and light. But that's not to say that's not a good reason, but it is fun.
All right, we have a couple of more minutes. Bob, do you remember what the psychic worker context was supposed to be?
Yeah, I wanted to, but this is maybe more for Sean and Osvaldo, if you care. But it's like the developer workflow that what?
I've got to go. I've got an interview and I need to help I'm shadowing.
So I'm okay moving it to next week actually. Because
awesome.
I was just going to show the thing that we discussed in our one-on-one, Maren, like a little bit complicated for developers now to provide context to Sidekick workers if that differs to whatever it was scheduled from the request and so on. And we don't want to introduce extra queries when we do that and so on. So I came up with an idea, but it works, but it looks a bit complicated. So we'll need a lot of documentation and helpers and stuff like that. And I wanted to run that by other people, but it can wait till next week.
Let's move it to next week. We are already basically over time, so yeah. Just a quick question before I add people to the other demo that is following up in 5 minutes. Jar and Skarbek are doing from the delivery side similar but not the same demo. So who from this call is interested in joining that? So I can add you immediately to the invite.
I'm going to join.
Cool.
Yeah, I'll join one if I can.
Awesome. I'll add everyone then. And then we can see whether you want to join every week as well. I kind of grouped them together on purpose, by the way. So cool. Let's take a 5-minute break and reconvene in the next one.